Students, have you ever wondered how computer make decisions? To understand that, let us dive into the world of logical gate of a computer architecture in today's class. So without wasting time, let us dive into the content. I am Nikita Vinay, your IT trainer. So come on, let's start the class. In today's session, we are going to understand everything about logical circuits and design. So we are understanding about logical gates in a computer architecture. First of all, what are logical gates? Logical gates are fundamental building blocks of a digital circuits in a computer architecture. So these are the building blocks of a digital circuit in a computer architecture which will help us to work with the fundamentals of computer. They perform Boolean logical operations on one or more binary inputs. What are binary inputs? Before understanding Boolean logics and binary inputs, we must understand that our computer does not understand our common languages like English, Hindi, Kannada, Malayalam or any other local languages. Yes, you heard it right. Even the computer doesn't understand the English language. These machineries will understand only the language of binary inputs or a Boolean values 0 and 1. Why are logical gates important? Logical gates are essential for process. These are used to process the data, also used to manipulate the digital data. They form the basis of a complex operations, also the functionalities in a digital circuits and processors. They will understand the complex operations, also how they function, everything within digital circuits and the processors. So these are the common types of a logical gate. We will understand about it in detail in the next slide. How do logical gate work? Logical gate operate based on predefined truth tables. What are truth tables? These are the tables that will predict the output using the inputs of a computer system that dedicate the output based on the input combination, as I already said. They will use the input and they will produce the output using zeros and ones. They utilize the electronic components such as transistors to implement Boolean functions like AND or NOT, etc. Already we got to know some of the logical gates, but we will get to know about it in detail here. These are all the different kind of a gate. First one is single input NOT gate. This is a NOT gate with a single input, where we will get to know that single input or double input. This is the single input will produce single output. Here the second one is AND gate. The gate name is AND. So here we will get two inputs to produce single output. Again we will come through OR gate. These OR gate also will get double input to produce single input. Not necessary to say that every logical gate will have a double inputs. No, every logical gate can have single input, also double input, where I have given both the type of examples using gates. Now coming back to the slide, we have gone through the truth table. So we will get to know about the truth table for particular truth table that belong to particular gates. So this is the truth table that belongs to AND gate. This is the truth table that belongs to OR gate. This is the truth table that belongs to NOT gate. These are all the examples. We will get to know how these outputs were generated using these kind of inputs in detail in the next slide. Here are the empty truth table. We will understand how the output is generated in detail for the particular gates. First, let us understand about the AND gate. But before that, consider that 0 is a false and 1 is for true. AND gate is a basically multiplication of a two inputs where A and B both are multiplied. So any single false input will produce only the false output. As we already know that negative value is multiplied with a positive value will always get the negative value itself. 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0 and 1 into 1 is 1. So simple. AND gate is a multiplication gate. Now let us move on to the OR gate. OR gate, as the symbol indicates, it is a addition. So we will add two values to get the output. Here any single true input will always produce only the true output, because the 0 plus 0 is always 0, 0 plus 1 is always 1, 1 plus 0 is always 1. Here we have to understand the concept over here very carefully. 1 plus 1 we will always think about the 2, but in computer architecture we will not have any other numbers other than zeros and 1. So 1 plus 1 is 1. Next, moving on to the NOT gate. NOT gate is always an interchangeable gate where interchange of a true to false and false to true, vice versa. So here 0 to 1 and 1 to 0. I hope you are getting my point. Let us move on to the next slide. Further, we will combine multiple gates to produce another new gate. Here AND and NOT gates are combined to produce a NAND gate. where the truth table will also be combined to produce a NAND truth table. How we got this NAND value, we will get to know about it. This will be indicated as AB inside the parenthesis and the single quote. The value will be produced in such a way that false into false value will always produce true value. True into true value will produce false value. False into true value will always produce again true value. Here, as we know, 0 is a false value and 1 is a true value. 0 into 0 is true value, that is false into false, true value. 0 into 1, false into true, true value. And 1 into 0, true value, that is true into false, true value. And 1 into 1, true into true, is a false value. This criteria is already I have discussed as given below. NAND gate is exactly opposite to your AND gate. So, not of AND gate. In AND gate, we got false into false is a false value, false into true, false value, true into false, false value, that is multiplication of both inputs. So, 1 into 1 is 1. So, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1 is 1, that is true value. Now moving on to the next slide, that is OR gate and NOT gate are combined to form a NOR gate. Here also the truth tables are combined to form a NOR gate truth table, that is indicated as A plus B within the parenthesis and single quote. How does it actually works? Here the false into false value is always true, true into true value is always false, and false into true value is always false, that is 0 into 0 is 1, 0 into 1 is 0, 1 into 0 is 0, and true value 1 into 1 is also 0. How we got this? Exactly opposite to the OR gate, that is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1, that is true value, always a true value. We came across AND gate, OR gate and NOT gate. Also by combining the NAND gate and NOR gate also we came to know. Now moving on to the next slide, we will get to know about XOR gate and XNOR gate in detail. In XOR gate, any double true input will always produce only the false output, that is 0 plus 0 is always 0, 0 plus 1 is 1, and 1 plus 0 is 1, 1 plus 1, that is any two true values will always produce a false value, that is 0. Moving on to the XNOR gate now, this is exactly opposite to the XOR gate. So here we will add the NOT gate again. So 0 plus 0 is 1, that is any two false value will always produce a true value. 0 plus 1 is 0, 1 plus 0 is 0, and 1 plus 1 is 1. Any two true values will produce only the true value. Now where are the logical gates used? Logical gates are found at various levels within the computer system, that will from a simple arithmetic unit to complex processors. From processing simple arithmetic units to complex processors. They are also utilized in the memory units, input output units, and the control units perform specific tasks. In previous class we came to know the detailed structure of a computer organization and architecture. So here we will have a brief knowledge about it, where computer system holds main memory and also CPU, where user will generate the input to computer system, that is main memory. Main memory will receive it and pass it to the CPU. CPU will analyze whether it belongs to arithmetic and logic unit, or it belongs to control unit, or it is higher the capacity rate of a control unit, it will pass to registers. So it will be processed within the CPU if it belongs to the CPU, or else if it holds the lesser capacity than the CPU, then it will be obviously passed to the main memory again, or else the CPU will process the program and will generate the output to the user. Next, coming to the slide, when the logical gates are used? Logical gates are used continuously during the execution of a computer programs and operations. Whatever the programs might be, the operation might be, the logical gates will always be active. So they are activated whenever there is a need for logical operations such as data comparison, decision making, and data manipulation. Whenever the data requires data comparison, decision making, data manipulation, also the logical operations, these logical gates will be automatically activated and will be functioned accordingly. So who develops logical gates? Logical gates are designed and developed by computer engineers engineers and electrical engineers like you and me. Computer engineers will also design the logical gates. Also, the electrical engineer require the design of logical gates. They will also design it. Companies specializing in a semiconductor manufacturing produce the integrated circuits containing logical gates for use in a various electronic devices like micro component of a CPUs, motherboards, or any electrical circuits. Those are all designed by electrical engineers. Also, the computer engineers, they require the logical gates most. So here ends our unit 2 chapter, logical gates and designing. So whatever the doubt might be, you can post it in a comment section. If the video was helpful, hit the subscribe button, like the video, also share the video for the people who are in need. Thank you for watching my video. Take care. Bye bye.